Thanks for turning up, everyone. I know it's winter and it's been raining, so appreciate you coming along. So I'll just shout out to ActiveX, who are a joint venture partner on some of the ground. Rockland Resources is in the process of selling their ground, but they allowed me to show all the data. So it's Rockland Resources data that I'm showing predominantly. And Greg Morrison has done quite a bit of help with me with the Klondike, so a shout out to him as well. So this is an old photo of the Pentland Deep Lead, or the Cape River goldfield, and it was discovered in 1960s, led to one of the early gold rushes, the earliest gold rush in northern Queensland. So after this gold rush, there was Georgetown and Charters Towers, but this was right at the very start. And it's quite interesting thinking back to what it was like for these guys. They did it pretty hard. I think they had ended up with a whorehouse and a pub and gunfights in the streets and all sorts of stuff going on. So it's quite interesting to try to think back what it was like back then for these guys. And as I come into this talk, I'm talking about stream sediments and soils in particular. And I did canvass a few people as to how hard they've tried to collect a sample, or what an adventure they had. And Mark Berry, he'd actually used a horse to move samples. And Simon Tier, he had a 1 centimetre ice layer on his sieve as he tried to do sieving. So my point with that is that we can spend a lot of time trying to get these samples. They can be pretty hard to get. And I guess the emphasis of my talk is trying to interpret that data better through data mining. So I have just done some work for the IEA. And so this is straight out of something that's in print from them. So if you're not familiar, the IEA is the International Atomic Energy Agency, and they are doing a comprehensive document on managing uranium exploration and e-learning. So those things will be out in the next short little while. So you can keep an eye out for that. But as we come into any project generation, we're looking to climb the pyramid as quickly as we can. So, from district scale right up to the mine, for project generation that I was involved with for Rockland, we tried to be in this zone where we had ore grade intercepts on some ground we were acquiring, and we were hoping to be able to apply modern methods to that. So I guess just a little bit of journey for us in terms of how we ended up with the project at Pentland, and what sort of methods we used. So a shout out to GSQ, because in 2016, the EX3 database got expanded by 26,000 holes. And so that was a really great place to start to look for new ground. And so what we did, or what I did, is converted every assay to equivalent gold, regardless of what commodity it was, for every rock chip and every drill hole. And then created queries which look to sum each of the drill holes, come up with an overall rating of equivalent gold, and look for any drill holes that ended in mineralization, those sort of things, because it was quite certain that there was a lot of activity in the 80s, that when a lot of this drilling was done and being captured, and the idea was that, explorers had walked away from that early and there was opportunity to be had. So that was a process. And you can see on the diagram there, we ended up with 6 projects, up to 64 metagrams per tonne as a summed average. Some places were a bit lower than that, but there was all these projects had some reasonable ideas. There was some mineralisation there. And at this stage, we were agnostic to what commodity it was, but it turned out that each of these was gold that was giving that result. So Charters Towers is obviously west of Townsville, and Pentland is west again. So this is a metallogenic map from 2015, and it shows intrusion gold, orogenic gold, and epithermal gold, volcanogenic gold as well, volcanic BHMS mineralization as well. So where does, and this is a very, very prevalent field, 20 million ounces gold, been quite a decent amount of production. For the Pentland area, which is off to the west, there is a deep lead there, which is 60,000 ounces. So it's quite a lot of gold in that small zone, 1 to 2 kilometres. Obviously led to that early work by the prospectors. Thalanga VHMS is nearby within that province. And what we came, as we came into this area, it was evident that most of the orogenic gold could probably be reclassified as IRGS. And so that was one of the things we were doing. And we also found that there was potentially a myelinite gold event as well. So we were really trying to come up with new ideas and a new story for the area. With the Pentland deep lead, there's some papers that talk about a lead, the gold from a lead is probably travel less than 15 kilometres. Hopefully probably less than 7. Sometimes leads are right close to the mineralisation. But this is some work by Garrett and Tate, who put a bit of a target on the Pentland deep lead. Straight away, you can see in the centre of the target, the lead is bisected by the Cape River, and that's why it was called the Cape River Goldfield as well, and township. And what we do know, we don't know lots about the gold, but we do know that it was waterworn, so it's travelled quite a way. And there's probably two lots of gold. There's a coarser gold and a finer gold. And basically the finer gold, hopefully we think has come from a large IRGS style mineralisation, maybe a porphyry. So the other thing we know about it is that the fineness is around 93%. It's just verbal fineness, but there's some calculations have been done in the field, and that is a high fineness, high gold silver ratio. So that again would imply more of a IRGS style mineralisation, maybe similar to Kidston or Mount Lation. So shout out to Simon Beams and Greg Morrison for lots of work that they've done in the Charters Towers area. And, you know, I guess my talk is leveraging some of their work that they've done over the years. And a lot of people have seen this cartoon. It brings together the epizonal, epithermal level down to the plutonic level. It classifies a lot of the major deposits, based especially on the metallogenic relationship, which you can see on the right-hand side of the slide, and the styles of mineralisation. And so coming in here, this is what we were trying to leverage. At the bottom, you can see that the element class can be translated into whether you're in the core and maybe whether you're a permacarb system. And also there's been some age dating from the GSQ, which challenges some of the ages that we have previously around the Charters Towers, brings in a 310, a 330, 320 for IRG, and also a potentially 380 plutonic IRGS as well. So a couple of different ages that have come in. And also in the field, we did find an area which had a lot of myelinite with gold related to it. So that's potentially another style that hadn't been previously recognised in the local area. So just stepping through the geology, and you can see Pentland is in the middle. Very faint is the Rockland tenements. and Active X as well. You can see the Thalanga mine and the mineral events. So I was just going to step through the geology just so you get a sense of what's happening. So the oldest is the Precambrian basement, which is the Cape River metamorphics. And that is probably the main lithology in the Pentland ground, followed by the Cambrian and Ordovician volcanics and granitoids, gneisses. And this is also the moment where you've got the VHMS Thalanga mineralisation in the blue. So here we have our Silurian to Devonian, and perhaps a myelinite fits into a Silurian age. And also we have Devonian granitoids, and one of those new ages would put it more into the Amara granites and the leucogneiss of the grass tree. So that is new. And then after that, we have the permocarb event. It's a range of ages, and there is a Permian and a Carboniferous gold event. So that's on there as well, as a series of granites that have come up through the sequence. And lastly, we've got the younger age. So we've got the Galilee Basin, and there's actually some basalt up to the far north, which brackets the project. And we've got a reasonable amount of cover. And I put that on there just because the flavour of this talk is soil and stream sediment sampling. So obviously the cover is a big impact on the project. And, you know, we've got cover over more than 50%. A fair bit of that is transported. Right in the middle there, you've got the Pentland Deep Lead, which would be the event that's come in. So the question is, where has that Pentland Deep Lead come from? Has it come from an IRGS or some other mineralisation? There's a lot of small veins in the Pentland district. So, but obviously the prize is a larger porphyry style plutonic event. So just, I guess, peeling back all those layers and just putting on those camps. We've got the coloured, so you can see the pink and the red and the orange IRGS. And I've also got in red the Elamite fault, because we found mineralisation right along that fault. It seems to be a big part of the mineralisation story for the Pentland area, and was new for us, discovering that was such a strong control on mineralisation. And what we found is that, I guess, this drilling that's shown here, some of it was ours and some of it was previous drilling. Mount Lation, Normandy, Newcrest, a lot of the big players had a go at this area back in the 80s when it was recognised as being similar to Kidston and Mount Lation and Ravenswood. And so you can see probably the take-home message with the drilling is that there's some reasonable grades. They're not just thin. There's some fairly thick sequences and spread out, especially along the Elamite fault trend. And there is a bit of a flavour here of the IRGS in the Mount Remarkable area towards the bottom, the 47 metres, that has a lot of molly copper associated with it. It's a porphyry. And then if you look at my right-hand side is looking at the screen, there's an antimony prospect, which was 120 metres at 0.12 antimony. So with gold associated with that camp. So that's a epithermal flavour or epizonal type flavour to the mineralisation. So there's a bit going on, and certainly we've tried to have a go at understanding it and putting an age and a mineral system to the gold that we're seeing, which I think has been really important, and Greg's been great with helping with that, Greg Morrison. So our exploration is pretty standard. I feel like we didn't do things too different to other people. You know, we've done some orientation work. I believe in integrated targeting. We've used experts, apart from Greg, we've used Nick Tate and Simon Beams. Certainly for us, we're favouring areas under cover or a little bit of cover, because the old timers would have found the good stuff that was outcropping already, right? So we're looking to leverage what the old people, old timers have done, the previous companies that have come in and got the easy stuff, and we're looking to, you know, expand the mineral system and expand the areas a bit. So certainly we did soils and streams and magnetics, drilling. I'll just, this is Nick Tate at one of our alluvial areas. So he and I were digitising every pit we could find to help trace the alluvials back to Mount Davenport, which is just there. So, and in terms of what we did, I also shout out to Nick Tate and his 20 golden rules of exploration. If you haven't looked at those yet, you should, because they're really good. And certainly, you know, he would say things like, it's brown, bag it. And he'd say, follow the alluvials, follow the geochemistry, but don't believe the geochemistry. There's a whole bunch of really interesting statements that he makes. This is the project scale magnetics. You can see the Element fault in red running to the northeast. Did lots of soil sampling was done in the past. And what we did is we really explored the northern side of the river, because that hadn't been explored almost at all. There was hardly any drilling, hardly any soil sampling. And basically wherever we went with the soil sampling, we got a hit and we kept going. So we got numerous places over 100 ppb gold. And so it just kept going as we followed the Element fault. So that would be our unfolding story for us. And we did, because we had a bit of cover, we did try using a 6x6 air core RC rig, which is pretty cool. So I really like that, because it had such a small footprint in terms of disturbance. And we did reprocess IP, which is something that a lot of explorers do as they come into these areas where there's been work done in the 80s. There's a certain amount of things you can do to leverage the old data. So that's sort of the background. And now the second half of the talk is really about soils and streams. So whenever you talk about soils and streams, it's kind of perplexing when you try to think what's happened to that poor little sample as it's gone through its life. You know, it's been eroded, it's been weathered, you know, the water table's gone up and down, it's been transported probably, organisms have been involved. There's a whole lot of stuff, right? And we're hoping that that sample that we've collected reflects the basement geology, and in particular reflects mineralization within that. And you know, so we're trying to be careful with the fraction we collect, the spacing. So we've always got a cost benefit analysis going on, where we want to collect enough samples for it to be meaningful, and represent a catchment or represent an area, but we don't want to go overboard because it gets expensive. And you have to make decisions about the depth and things like that as well. So in the end, our target is potentially swamped by background response. It's potentially subtle and weak, and it may be undersampled. So there might be only one sample that is anomalous that leads us into a place. So the sampling is really important, which was at the start of my talk, I said that. And so what was Rockland's approach? So Mark Perlow did some work with me right at the start, and he was rightly so in saying that a clay fraction would be a good place to start, a good thing to use, and doing some orientation work, which we did. And what we ended up using was mostly the ultrafine method, which is developed by the CSIRO. There's a Lab West in WA, is the only provider of that. So we would ship our samples off to Lab West. It's a clay fraction. ultrafine method. Also, what I like about it is that only a 200 gram or so sample is usually required. So, you know, you don't have to have too much, you know, you can have a lot in your backpack, which makes a difference if you're doing a stream sediment sample and got a long way to walk. But the flip side of that is you have to get a fine sample. And so sometimes if we were suspicious that we didn't have fines, we would do like a little bottle test and see whether it was soluble and try to have a guess in the field. And we could always take an extra sample if you wanted to, or a bigger sample. You know, it certainly weren't limited to 200 grams. But you know, the samples were obviously a lot smaller than, say, a traditional -80 mesh sample where you're looking to probably 3 kilograms or 2 kilograms. So this just zooms into an area, and this is this area north of the deep lead. So you can see the deep lead and Cape River transecting it potentially. And to the north, our magnetics was indicating that the LME fault was there, and there was some compensation zone, a structural story that you could put to that area. So we did some recon, found some float with mineralization, did some soil sampling, and we pretty quickly ended up with a picture like this, where I think the scale there's 500 meters, several over 100 ppb gold anomalies, and we've ended up drilling in one of the areas, and the black is the drill holes, and the hole PLRC12 had 33 meters at 0.8. So that was sort of the story for this particular area. And of course, we could look at the pathfinders and work out that we're probably within a plutonic system, maybe the Permian. We're near the core, which might be a bismuth tellurium core with an arsenic antimony relationship, base metal relationship. Other samples show that it was particularly low on the pathfinders and heavy on the gold. So the pathfinders are low part of this. So this is where we did one of our orientation surveys. So the question up near hole PLRC12 was what happened to the gold anomaly, because it dies off. And another question was, well, is ultrafine good for stream sediment sampling? We wanted to do a lot more of that. So this is all ultrafine data, but we had a couple of questions. And the other question would be, there's a flavour there of gold and arsenic, and gold, arsenic, antimony. And how do we start to combine elements and really understand the pathfinders in relation to the soils, given that there's all that other stuff happening in terms of background? So the orientation results, we did a couple of lines of partial leach soils, and really there was no difference to the ultrafine in this place, this location. So, so in terms of soils, we were happy that ultrafine was at least comparable with the partial leach. And for streams, the ultrafine was amazing. So using a very similar analytical method, collecting a -80 mesh, fairly standard sample versus the ultrafine. The ultrafine started off at 42 ppb versus a -80 was 6.3, and that was within 250 meters of the mineralization. And then those kept coming down. The -80 went straight to background, but over a kilometre away from the source, we're still 11 ppb for gold. So it was an excellent result, gave us a lot of confidence. Of course, there's pathfinders that we can talk about as well, but certainly I'm just talking about the gold here. It was amazing. So for data mining, it's important to make sure the data's good to use, fit for purpose. And fit for purpose means you don't just halve the detection limit, which you can easily do for basic analysis, but for data mining, you don't want to create false patterns, and halving the detection limit creates a false pattern. So you want to impute data. So here our gold our golden plot is there, and you can show that you can see it's highly skewed, and the detection limit's 0.005, and we've used a method to impute data at the very low end rather than just halve the detection limit. And then I've done a CLR ratio transform, which normalizes the data, which is great, but it also corrects for the compositional aspects of the data. So basically, as your gold's going down, other elements are going up. They're all interrelated because it's a concentration. So to break that, there needs to be some fancy maths to try to have it so that each of those elements are behaving independently for the data mining. So data mining, there's lots of tools, and I haven't used all those tools that are in the wagon wheel there. But what we're trying to do is we're trying to identify subtle, complex patterns, and the data, the response might be non-linear. So straight away, the data mining is great because it can actually handle non-linear aspects in the data and in the patterns you're trying to find. And I've put in blue there my favorite tools, I guess. And if you're just looking at it very coarsely, you'd say that random forest is for, helps with matching. Some of the other tools there, principal components, TS&E, that's for condensing. And then there's other tools that are for grouping. And it's very ambitious to put a wagon wheel like this together because actually some of the tools don't fit, or they fit in more than one category, right? They do more than one thing, like they reduce the dimensions of the data and find groupings. And but this is, these are some of the algorithms that I like and have used. And so coming into the interpretation stages, we have, of course, understanding the model and the system, preparing that data, and then we just go through the data mining process, assessing the data, removing the background so that you can see those subtle effects, and then mineral targeting. And just to give you an example, there's also an interaction between these. Like, for instance, I've used principal components as an input to TS&E, which I've then clustered using dbScan. So there's a whole bunch of tools can be used in a whole bunch of different ways, and there's papers and guidelines on which ones are the best to use. But the overall ambition is to highlight subtle features and try to remove those background features which you don't necessarily want. So this is a snapshot for the Pentland area. And we've got our Cape River metamorphics, which is the Precambrian basement. We've got our Devonian granitoids up on the top end. And this is the attempt at modelling or isolating the background response. So I've withheld the pathfinders. We don't want gold in there at this stage. We just want elements that will help find background, right? So I haven't put the pathfinders in, I've taken them out. I've applied that data preparation and processing, and this is the result. And it's really great that, say, the red, well, I can look at the data and I know that's like a felsic response. We've got high thorium, hafnium, zirconium, and as we go from that pink to the brown, or the red in the geochemistry, we go to mafics with scantium, vanadium, and titanium. So this makes a lot of sense. And what's really good is that I know firsthand that majority of these samples are in areas of cover, and in reality, a lot of them I had a suspicion were transported. So I didn't even think necessarily that they were reflecting geology well. So it was a really good result. So of course, I can see from the geology map that it's reflecting geology. I know that in some areas it won't reflect geology, it might reflect the cover. There's some areas here where there's black soils, and other things going on. And this is an attempt to try to allocate every sample to a background response for our statistics. So has it worked? This is another prospect. And first of all, this is including the background. I think I'm just going to go back one slide if I can. Yeah, sorry, I skipped this one. So coming into this area, this is one of the places where there was a bunch of pits. There was 18 grams per tonne found by a historical explorer, and no other work, no drilling, no geophysics, no soil sampling. So we came in, we mapped the pits, we took our own geochemistry, we extended the soil sampling from over the pits well to the west, and that did identify a really large anomaly, up to 177 ppb, that was not at the pits. So the pits only gave 10 ppb gold, but the bigger anomaly was off to the west, and that's potentially due to less cover at that main pink gold anomaly. And as you come off that pink cover, pink area where there's a little bit of outcrop, you start to get more and more sandy cover. You get really suspicious that you're looking at just transported sand rather than any geology. But we persevered because we had a good gold response, and the observations we were making was to do with the magnetics and the structural story. It was noted that there was gold in granite as well as in the quartz, which is a big plus. And there was actually, when you looked at the pits, there was actually some rheology contrast and some chemical traps in terms of there was amphibolites in amongst the granite. So things lining up. Unfortunately, this prospect hasn't been drilled yet, but so I can't show you a drill hole. But this is the story that led. This is a soil story. So up at the top there, on our main anomaly high, it's 177 ppb gold. The anomalous elements are gold, tungsten, silver, tellurium. And then what I want you to focus on is the target sample. So that target sample has really low gold, well, lower for this environment. So it's right on the 50th percentile. For the data set for gold, it's 8.5 ppb. Some areas 8.5 would be quite anomalous, but for us that's median. And actually there's no pathfinders. So that sample, if you imagine that sample could be analogous to a sample at the edge of a survey for soils, or a stream sediment sample. How do we make that sample shine? How do we make that sample remarkable? Because right now it's not remarkable, it's not shining. It does look like it's along strike of the mineralization, but it's statistically, it's not doing much. And that's where the background correction comes in. So after I've taken that background out, there's been a percentile promotion of key elements, pathfinders. And the most benefit was tungsten. So tungsten percentile location in the data set went up 45%, and tellurium 37%. And so after that, yes, pathfinders are now recognised using the same approach, and they would be, in this case, gold, lead, tellurium. So if you're going to remember one slide from my presentation, remember this one, because it's an amazing result that a sample that wasn't anomalous has become anomalous, which is what we want for explorers. And with data mining, we can take that information, we combine all those elements together and come up with a rating. So on the right here, I've got a rating using all those pathfinders now that the background's removed. And you can see that it's now quite prominent. So my estimation is to improve that anomaly by 100%, which is pretty good. So another thing we can do with data mining, which is a bit of a curl for the brain if you haven't come across this before, but those who are familiar with principal components is basically reprojecting into a new space, which maximizes correlation. And so you could plot PC1 versus PC2. In this case, we've got a high-powered data mining tool called TS&E, and it has a projection of all the gold, highly anomalous samples. So anything that was anomalous has been put into here. I'm plotting component 1 versus component 2. And I've just coloured it, but what you can see is that those gold samples all have different characteristics. And TS&E, what it does is it tries to find groupings in the data set in that reprojected space. And so straight away, we can say, okay, this is what we expected. There's some areas where there's high arsenic. There's some areas which are high antimony. This is the different flavour that's in the gold results. And if we looked at a group, this is one of the groups. We can start to see the relationship. So if we looked at that group, it's quite high, obviously in gold, but it's high in bismuth, tellurium, silver. And what I wanted to show here also is it's low in arsenic and thallium. Now, sometimes people do Z-scores and combine elements, and that can be good if you've got a high, but sometimes the distinguishing feature is you've got a low. You've got, low arsenic versus another area with high arsenic, which actually means you're in a different part of the system, if you recall back to the epizonal cartoon we had at the start. So we can understand what makes each of these groupings tick in terms of what's anomalous and what's not. And what else is interesting about this approach is that we could feed into it what we want to find. And so at that Pentland deep lead, there wasn't much to see. It's been mined out pretty heavily in the 80s. But I did find a float sample, and I think it was just a really solidified quartz sample that hadn't been turned into gold dust. And so assuming it's a big assumption that float sample came and was part of the same system as the Pentland deep lead, then we can feed that information in and say, well, where else is the signature the same? And in this case, it's that group that we were looking at. We can put information together about what characteristics that rock chip has. It's a medium comb quartz, interstitial crystalline quartz. There's a little bit of copper there, along with the pyrite, and it's 0.3 grams. And we can actually say, well, that's part of a bismuth tellurium intrusion plutonic. So knowing where that sample fits within the different characteristics within the area, we can go and look for that, which is the final part of my talk. So if we're looking for that, it actually turns out that example I was showing, which was from the Deadman's camp, is one of the areas where it has the same signature as Pentland deep lead. So we have a lot of samples that are over 30 ppb, some that are over 100, different anomalies with different flavors, but we can now apply discrimination and upgrade the anomaly if it's like the Pentland deep lead. So it's a matching process. So that's the last of my talk. This is the conclusions. Thanks for listening. Alluvial miners, they needed to be, they're making a living out of it. They are careful to capitalise on the effort they made. They were very careful to use the right material to do their panning and their sieving. They needed the right tools. They were very quick to remove the rubbish. It was either rubbish or it was gold for them. We're a bit more intelligent about that. But and you can see that when I don't know if you've ever done panning, but the last stage of the panning is the final swirl, where you're trying to, maybe separate out your pyrite fines from your gold. and hopefully you've got a little tail there that shows you that you've got gold. So there's a finesse involved with it, and those principles are really important for my talk, because with data mining, we're kind of trying to do the same things. So for us, we use the ultrafine method, and we're very aware that there's a complex nature to the samples. There's a mixture, hopefully there's geology involved, but there's other factors going on, and the sampling might be quite coarse. The anomaly might be quite rare. And so data mining has been used in this case to define subtle anomalies and to unravel the complex relationships, and finally to match the signature. So, I think data mining has a great place with soils and streams. Sometimes data mining is, or AI, machine learning is kind of a bit of a black box, and I haven't tried to go into how the tools work. To be honest, I don't know how all the tools work. I know how a few of them work. But I feel like this is an area which is coming more and more into our geoscience, and has a really great role to play with our soils and streams. And the interesting thing is that we can apply this to our historical data as well. It's not, it can be done tomorrow to whatever data set we have, as long as we're careful with the data processing aspects as it goes in. So thanks all for coming on a winter rainy day, and hang around, have a chat if you want.
Thanks, Jeff. For those at home, if you've got any questions, please start using the Q&A and we'll get to them. For those here, do we have questions? There's one.
Right. And thanks, Jeff. That was a really great talk. I'm one of those guys who was working around in this area in the late 90s and the early 2000s with Newcrest. I've run around these hills, or actually it's not that many hills, it's a bit flat. And it's a lot of saprolite, and a lot of people running around with metal detectors finding gold. And we were out there blasting RC holes, following up the Simon Beam's TerraSearch database anomalies and the mag stuff. And we didn't really have much success, but maybe at that time the price of gold was very different, and maybe it has contributed to your hunt. What I would say is the area does have a lot of good geochemistry, but I think what you're onto with the machine learning stuff, especially the T-SNE stuff, that is the way forward. It's a really tricky area to explore, and I don't really have a question. I'll just say good on you for having a good solid crack at that. Poke in more holes. That's the way you will find it. That's it.
Okay, thank you.
Thanks, Rob. Oh, question over here.
Yes, interesting talk. After all your data mining, I still think you'd drill the pink area, which you identified before your data mining. So what's the point?
Oh, well, I guess you're right. The pink high of 100 ppb gold, you just drill that. That's ready to go. I guess the point is that if you've got coarse sampling, so say you start doing soil sampling at 200 by 200 meter samples, or streams where you're trying to have a catchment that is representing, say, 2 kilometre catchment, then that sample becomes so important. So that's a drill ready target, and the data mining doesn't help there necessarily, but it helps you create a framework for elsewhere.
Thank you. There's a couple of questions from home. From Henry Tabar asks, could you please describe the weathering domains, depositional versus relict or residual, versus your samples and results? Are there any pattern? And is transported cover worth sampling?
I'll start with the last one, because that's the easiest, I think. Transported cover is not worth sampling, I don't think, or be very wary. So that's where an orientation survey comes in. But I guess I tried to portray that in the field, you're faced with a decision: is this transported or not? And my answer is you may not know. and you might need to take some samples at a coarse spacing to see if there's a response, because certainly I was surprised in a number of areas where I even had a discussion with a geology colleague, and he was like, "You are wasting your time collecting this sample. We should move on." And we did collect the sample, and it did end up being anomalous. So, so it's a tricky question. And I think it comes down to looking at nearby outcrop and trying to see what the profile is, and doing orientation and being observant as you can. I think the other question was really quite complex. What are the different regimes of regolith in this area? And I'm not a regolith geologist, and I don't know if I'd be able to answer that in any succinct or short fashion. I guess if you remember that the plot of the background, there was quite a few zones that there was some really good relationships with the geology, but there was other zones which were due to cover. And, you know, there's places like a black soil where obviously you've got a certain regolith regime, but there's other areas where it's a bit different. There's no laterite per se in this area, just some pisolites in places. So for the most part, it's what they call a compacity formation, which is a tertiary event, has a lot of sand and soils related to it.
Thanks, Jeff. Question for me. Obviously, in a lot of these areas, we're looking at historic data compiled from lots of different companies. So there's always going to be different data densities and elements assayed for and the like. How do you deal with that? And I guess part of that is, can you, if you stripped out half the data, do you still come up with similar results?
If you stripped out half the data, you could come out with a similar result, because it depends which half you take out. Certainly historical data, it's standard geochemistry 101, that you have to be careful what your below detection limits are and handling those. And there's some decisions to be made about whether you have complete data sets. You know, this approach would work with, say, 8 elements versus more than 50 elements. I guess the whole premise of data mining is the more data you have, the closer and quicker you'll come to the truth, or at least you'll be better off. But hopefully you saw that that standard pre-processing is important for data mining, and how you handle those below detection limits, and having normalized data is quite important too. And so sometimes, if the data is incomplete, then you might not use an element because it's not complete enough. Some data mining handles nulls, some does not. Some of the tools, most of those tools assume data that is normalized. So that is an important aspect. So I don't know if I've answered your question, but that's kind of the best I can do, I think.
Any other questions? Another one from Doug. Here we go.
So you had an intersection there of 33 meters at 0.81. Did you follow it up? And if not, why not?
No, there was dots around that one, and we did follow it up. The hole next to it was a diamond hole. Wasn't quite so good. The result I showed was an RC hole. But I guess, I was just showing you the cherries in amongst that. There's a lot of, I guess, as I said, there's been drilling in the 80s by a number of big companies, and we've done our own. I guess the background story is we are selling this project, so there's some drill holes and soil samples that are yet to be done. So it's a work in progress, and
it's the upside potential.
Yes, and I guess the example I had. I think the example the hole you were talking about didn't have a soil sample just to the north. The gold had dropped off to the north in the soils. So the question is the mineralisation dropped off, or is it still there and just been obscured by cover? And I guess that comes back to my original premise, which is, well, if you do the background correction, then at least you can potentially find that mineralisation, even if it's got a bit more cover associated with it. But we didn't, we started to get pretty scared going to the north on that hole because there was no soil anomaly. So we were starting to wonder about that.
Another question from folks at home, David. When considering your previous slide, pyramid on project workup, where best do you see this type of data mining best applied from a cost-based analysis point of view?
Well, firstly, Mark Perlow once said to me, Jeff, even though if you see a lot of streams that have been done in the 80s, don't be scared to do it again, because they probably didn't use enough elements and they probably had detection limits that were pretty average. So I guess the question is, at what stage do you do data mining and streams and soils? It's a little bit hard to say. I guess streams is usually very greenfield, early stage. Soils is the next step where you've got some indications of anomalies. Data mining is applicable to any soils and streams that get collected. Of course, data mining can be used with drill holes and geophysics and all manner of other ways, which starts to get into a bunch of other tools and AI and machine learning. But I think my answer would be that early stage. I guess for our area, streams and soils was the #1 targeting method. So certainly we collected baseline magnetics at a 100-metre line spacing. We did IP. What gave us the most number of targets? It was soils and streams.
Thank you. I've got another question. We are really good at going to the bits that we're interested in. And we bias our sample collection by going to those areas. So, we don't go and sample areas we're not interested in for, cost reasons. Does a process like this benefit from doing that, actually finding out, well, what is background? Because if we're always sampling within the area of interest, we're hopefully sampling within an area that, we're already above background. Do we need to go out and look at other stuff?
Well, that's a part of that question, but you might need to rephrase part of it. But as you were talking and asking that question, I was thinking how one aspect of the soil sampling is that, like I tried to remove the background, which had a large geology component, but the flip side is you can use the soil sampling to map your geology, and that can be a game changer in understanding a rheology contrast or a subtle change in the mineralisation that is not necessarily reflected straight away in the gold or the key element you're chasing. It might be in something a little bit different. So, even a long-lived project which has soils and that's been looked at a lot, I guess there's always extra things that can be extracted with data mining, I'd say.
Any other questions? No, looks like we're all done. We're all done at home as well. I think we were over 7 anyway. So I'd like to take a moment and thank Jeff once again.